All right, so let's be honest. When you think of algebra, you probably think of boring textbooks, right? Well, what if I told you it's actually a secret code? A code for solving all kinds of everyday mysteries, even what's in your lunch. And today, yeah, we're gonna crack it.
I mean, think about it. You're grabbing a quick bite to eat. You see the total calories on the receipt. But what about each individual item? How many calories are in just the fries or just the soda? It seems like a simple question, but it's actually a classic little puzzle, and it's just waiting for us to solve it.
Okay, so let's open up our case file here. We've got this guy, Joe. On Monday, he gets a lunch combo. 1 order of fries, 2 sodas, and it all adds up to 620 calories. Then on Tuesday, he kind of switches things around. This time, it's 2 orders of fries and just 1 soda, for a total of 820 calories. The tricky part? The menu doesn't break it down for us, so we're definitely left with a mystery on our hands. So this is our mission should we choose to accept it. We've got to untangle these 2 different days to figure out the hidden numbers. You know, the calories for just 1 order of fries and 1 soda. We're going to be the detectives on this case, and our secret weapon, it's not a magnifying glass. Nope, it's algebra. Okay, to crack this case, first we need to know what we're actually looking at. This whole calorie puzzle, it's a perfect example of what mathematicians call a system of linear equations. Now, I know, that sounds super complicated, but trust me, it's not. It's really just a fancy way of saying we have a couple of related mysteries that we have to solve together at the same time. So, what's a linear equation? Well, it's just an equation that would make a perfectly straight line if you drew it on a graph. Super simple, no weird exponents or square roots. And when you have a system of them, like we do here, what we're really looking for is the one single answer, that one set of calorie counts that makes both of Joe's lunch orders totally 100% true. And here's the really cool part. This is where we translate our everyday problem into the language of math. Let's make it easy. We'll use F for the calories in fries and S for the calories in a soda. So Joe's Monday lunch, that becomes F plus 2S equals 620. And his Tuesday lunch, that's 2F plus S equals 820. And just like that, poof, our mystery now has a clear mathematical structure. We've got something to work with. And hey, would you look at that? Our equations, they kind of just fell perfectly into what's called standard form. That's just AX plus BY equals C. Basically, all the variables are lined up on one side, and the total number is on the other. This setup, oh, it's absolutely perfect for our first, let's call it an interrogation technique. All right, technique number 1. It's called the elimination method. And honestly, the name pretty much says it all, right? The whole goal here is to cleverly mess with the equations just a little bit, so that when we add them together, one of our variables, one of our suspects, just vanishes. It gets eliminated. And that makes the whole case way, way easier to solve. Now, the logic behind this is actually rock solid. Just picture an equation, like a perfectly balanced scale, you know? The rule, the addition property of equality, says if you add the same weight to both sides, it stays balanced. Well, we're just taking that one step further. We're saying if you have 2 separate scales that are both perfectly balanced, and you combine everything from both scales onto a new, bigger scale, that new scale is going to be balanced too. It just works. So here's our game plan, our step-by-step guide to solving this thing. Step 1, get the equations in standard form. Check, we already did that. Step 2, we need to make the numbers in front of one of the variables opposites. You know, like having a positive 2f in one equation and a negative 2f in the other. Then we just add them up, solve for whatever's left, and use that answer to find the very last piece of the puzzle. Okay, so how do we get those opposite numbers? Let's take a look at the f variable. The second equation has a 2f. So for this to work, we need a negative 2f in the first equation. And how do we do that? Simple. We just multiply that entire top equation by negative 2. The only rule is you got to do it to every single piece of that equation to keep it balanced. Can't forget that part. And now, this is the magic moment. This is where the elimination happens. We take our new modified equation and we add it straight to our second original equation. And watch this. The minus 2f and the plus 2f, they just cancel each other out. Gone. Eliminated. And look what we're left with. Negative 3s equals negative 420. Now that is an equation we can definitely solve. So we are this close to figuring out the calories in a soda. But hold on. A good detective always knows all the tools in their toolbox, right? It's really important to know that elimination isn't the only way to solve these things. There's another awesome method called substitution, and it gives us a completely different angle to attack the problem from. And knowing when to use which method, that's the real key. Elimination, the one we're using, is just fantastic when your equations are already lined up all nice and neat in that standard form, just like our calorie problem was. But substitution, that's your best friend when one of the equations is already solved for a variable, like it says y equals something. Then you can just plug it right in. It's all about choosing the smartest, easiest tool for the job.
Okay, enough with the sidebars. Let's get back to the main event. The moment of truth. Our elimination method left us with one super simple clue. Negative 3ts equals negative 420. So let's solve this thing and crack this case for good.
It's a one-step problem now. We just divide both sides by negative 3. And we get s equals 140. Boom! Our first suspect is unmasked. One soda, it has exactly 140 calories.
Okay, so we've got the soda. Now we just take that piece of info and plug it back into one of our original equations. Doesn't matter which one. Let's use the first one. F plus 2s equals 620. We know s is 140, so that's f plus 2 times 140, which is f plus 280 equals 620. Do a little quick subtraction, and there it is. F equals 340. The fries mystery is solved. They are 340 calories.
But wait, a good detective always checks their work. Let's see if our numbers hold up. For Monday, one order of fries at 340 plus 2 sodas at 140 each, that's 340 plus 280, which is 620. Perfect, it checks out. Now for Tuesday, 2 orders of fries is 680 plus 1 soda at 140, that equals 820. Yes, another perfect match. The numbers fit, the logic is sound, case closed. So yeah, the case is closed. But you know, the real takeaway here isn't about fries and soda. It's about the incredibly powerful tools we just used to figure it all out. So the last thing we need to do is have a little debrief. Make sure we know how to choose the right tool for any future mystery we come across. So why does this even matter? Because picking the right method makes you faster and way less likely to make a silly mistake. Here's the bottom line. If your equations are all lined up neatly in standard form, elimination is almost always going to be your best bet. But if one of your equations already has a variable by itself, like y equals 3x minus 6, then go with substitution. You'll save yourself a ton of work. It really is all about working smarter, not harder. You know, once you see it, you can't unsee it. You start noticing these little algebra puzzles everywhere. They're hidden in comparing phone plans, in figuring out a recipe, even in planning your budget. The world is literally full of these systems just waiting to be solved. So the only real question left is, what mystery are you going to solve next?